to absorb excess water, excess base, or excess acid. The buffer solution also contains a significant amount of the conjugate base anion, A negative. If I add excess acid to the conjugate base, it will create more of the acid. The equilibrium shifts and the concentration of hydronium is kept constant. Acid-base conjugate pairs will swing back and forth just according to Le Chatelier's principle. Adding excess acid, H3O+, causes the equilibrium to shift as well. These came out pretty dark. Hopefully yours printed better. I'm going to just put this aside, and I'm going to do, hang on. I'm going to grab a blank sheet of paper, and I'm going to draw better what we've just drawn. So I'm going to encourage you to draw this with me and kind of talk through buffers. Pretty important concept. Let's suppose I'm going to create little bar graphs, all right? And I like to show this all in one picture instead of separate pictures. And I'm going to put, like, the size of the bar graph represents the buffering capacity of this particular conjugate pair. Let's say I have a weak acid, and I'm going to use H, you want to use HA or HX, whatever you like, but HA to represent a weak acid. And then its conjugate would be A negative. So a conjugate pair. In one direction, and we'll end up going two directions, let's suppose in one direction we add base, something like sodium hydroxide, some strong base. Alrighty. Well, a base consumes the acid. So if I add base, the acid is there to neutralize that excess base. So just showing that the acid goes down, but the base goes up. HA was consumed, and along the way we made more A negative. And if I could show the amount that the HA went down in the bar graph is exactly the same amount that the A negative went up. So they're consumed and produced in an equal amount. Let's suppose I add more acid to this buffered system. So these two are systems acting together to create a buffer. Pairs of chemicals in the same container that can either absorb excess base or excess acid. So let's suppose we add excess acid. Acid we can just write as H plus or H3O plus. We'll just go ahead and write that as hydrogen ion. That's going to represent excess acid. An acid will react with the base to cause neutralization. The acid consumes the base. So along the way, the base, A negative, decreased in concentration, and, very neat, the acid increased in concentration. H plus will combine with A negative to form more HA. The acid will react with the base, combining together. The acid uses the base to produce even more HA. Adding base reacts with the acid. The acid goes down and I make more base. The system of buffers. The buffering capacity, there is only so much acid and base. If I use one up completely, we'll start to see a swing of the pH. So they're systems together. They can be either an acid and its conjugate base. It can be a base with its conjugate acid. They act as a team of chemicals, helping to prevent a swing in the pH of a system. Absorbing excess base makes more base. Putting in acid makes more acid. The buffering capacity is only as great as the amount of the buffered solutions you combine together.